is my favorite subject and a very challenging class. And if you ever take it, you should do more than just pass.
Hey guys, let's figure out how to find symmetry algebraically. Line symmetry is where graphs have a line of symmetry if they can be folded along the line so that the two halves match exactly. A couple of examples that we've talked about for is things that we've been focusing more on line symmetry for about the y-axis. So these are three examples of where the phrase I have, I call it evenly, and that ly is kind of to show that it's symmetrical about the y-axis. Okay. Alright, so we also talked about point symmetry. Graphs that have point symmetry, if they can be rotated 180 degrees with symmetric to a point and appear unchanged. Okay? I forgot what our letter. I can think of. There. Cubic. Right, symmetrical about this point. I can take this quadrant and rotate it 180 degrees and it'll actually look like. Okay, so how do you find this algebraically? Well, replace x with negative x. Let's start. Every x value you see in your polynomial, you're going to take the x and you're putting a negative x. And then you're looking at these results and you're going to compare it below. You're going to get one of these three conditions. If it's equal to the original, it is called a even symmetry. If it is equal to the opposite of the original, that's called an odd symmetry. And if it is not, so not even and not odd, then it is called something, it's called neither. Why is this the case for these? Okay, let's say, let's do an example of even. Let's say my order pair here is 2, 4. And this is my x, and this is my y. And to test it below here in pink, you're going to replace every x with negative x. So, if I take this value and make it negative, or opposite of what I have, you get negative 2. And then your y value actually remains the same. So this is essentially the opposite of x, and my y value remains the same. Well, if you graph this, what do you notice? The symmetry is on the y-axis, and that's why I call it even. Okay, so the big idea here I just presented is that if you take the opposite of x and your y values are the same in blue there, then it is even symmetry. Let's try the same example. Let's try 2, 4. And then I'm going to go down here and replace every x with negative x. So this is going to become negative x. So the opposite of positive 2 is negative 2. And it's saying if I get the opposite of y. So the opposite of y would be a negative 4. because y is positive 4 is opposite of negative 4. So if I graph that negative 2, negative 4, you get an order pair down here. And that is odd because it is symmetrical. Is symmetrical about the origin, right? It's rotated 180 degrees. Here is 90, and then this is another 90 degrees in this direction. Okay, and you can kind of think about it, like some past two examples that I've just done. You can think about these as, you know, a linear is an odd graphically, right? And over here, this could be like a quadratic. Okay, let's go to neither. Okay, let's say you put in a point, 2, 4. And you already know where these kind of pop up. If it is an even, it would have popped in over here. If it was an odd, it would pop up over here. But let's say the point I get is here. Okay, and let's just say I just draw a graph here. Let's say my new answer is 4, 4. If I take the opposite of x, which would be negative 2, this is not negative 2. Although I get the y value, I'm going to take the opposite of x, and I get either the same or the opposite. So remember, graphically, this would be a either. So those are kind of just 3 quick conceptual ideas of the symmetry, and then we'll have a bunch of other examples of it. See you guys.
Love man. You don't love man? What's wrong with you? I love man.
Alright, determine algebraically whether the functions are even, odd, or neither. To determine one of these, I'm going to have to make sub negative x for x. So every x value, I'm going to put in negative x. So there is an x. There's another x. And this last x. And then I'm going to use exponents. So negative x times negative x times negative x is negative x to the third times 2 is negative 2x to the third power. This becomes a positive 3x. Notice how this is not the original problem, so it's not even. Now I'm going to factor out a negative 1. If I factor out a negative 1, negative 1 times something will equal negative 2x to the third. Well, that'll be 2x to the third. Negative 1 times something will equal positive 3x. That is negative 3x. I'm going to look above here in this parentheses. Is that the original problem? Yes, it is. So I have f of negative x equals negative f of x. And that's why I have this phrase called odd x. You substituted negative x, and I say odd x, you get the original problem, it's going to be an odd function. If I use end behavior to kind of give myself a quick sketch, the highest degree is the power of 3. That is an odd. Odds look like linears, right? X to the first is an odd. So I know I'm going to start down and up. Because it's to the third power, it's cubic. If you actually factored it out, pull out an x, you'll get 2x squared minus 3. And you set each of those equal to 0. You work on x equals 0 and x equals plus or minus radical 3 over 2. So your graph might look something like this. One, two, yeah, that would work. And notice how if you graphed it something like this, to check that it is symmetrical around the x-axis, you'll just look going across, small bump, small bump. One line, one line. Okay? Alright, so I need to prove algebraically whether this is odd, even, or neither. First thing I'm going to do is I'm going to substitute in negative x for every x value. Negative x to the third minus 3 negative x squared minus 2 times negative x plus 7. Pay attention to the math operations. So this is negative x to the third power, so that's negative x times negative x times negative x. That's going to give me a negative x to the third. Here I'm going to use order of operations, so this will become a positive x squared times negative 3, so negative 3x squared. Negative times negative is a positive, so I have 2x plus 7. I'm going to look up here, and this is not the original problem. Because this is not the original problem, this is not... What does it cost? It's not even. Okay, let's double check by pulling out a negative. So, that'll become x to the third. You're just doing the opposite math operation, right? So that's a positive 3x squared, negative 2x, minus 7. Class, in green, is that the original problem? No, it's not. So this is not the opposite of the original, so it's not odd. It's not even, it's not odd, therefore it's neither. Now if you graphed it, x to the third minus 3x squared minus 2x plus 7. And I'll prove to you that it is neither. About the origin, symmetry about the origin. These are not exactly the same. Going across this way, there's a bump, bigger bump, smaller bump. These are not the same. So there is no symmetry about the origin. Therefore, the answer is neither.
Moses! Hey, what are we doing? Let's do it. Moses, tell me what to write. Yay! Rafi! What do we do next? Should I multiply 6 or the exponent? Yeah. What do I get? Thank you. Brenda, what do you notice about this? Okay, some of you guys did this. Raise your hand if you factor out a -1. Raise your hand if you did that. You don't need to. Let me show you why. Class, I see 6x squared plus 10. What am I going to write here? G of x. It's the original function. If it's the original function, the answer is even. Okay, from last semester, you should be able to graph this by hand and without the graphing calculator. Class, is this a linear function or a quadratic? Quadratic, so it looks like a... Okay. The 10 tells us to do what? Go up 10 units. And then the 6 just tells us that it's going to get... Let's see here. My graph looks like that. Class, can you cut that in half by folding it on the y-axis? Yeah. Yes, you can. And that's how we found that the answer is both even graphically, and we did that algebraically.
Alright, so we have g of x equals 2x minus x squared. At the very top, we highlighted something in yellow. Partner A, tell partner B. Read to them what's in yellow. Ready, set, go. Maurice, what does it tell us to do first? We're going to replace every x with negative x. Tell me what to write. Pedro.
2 times negative x in parentheses minus parentheses negative x squared.
Go ahead and simplify that for us, Andy G. Simplify. Positive or negative?
Negative.
So we say negative 2x minus negative x squared. Positive x squared. Okay, here you might need to factor out a negative. Everyone say factor out a negative. 20 seconds. Write something in this parentheses. Remember, you can always check it by distributing. Partner B, tell partner A what you're writing in the parentheses. Kalani, what did you write? Say that again. I can't hear.
I need another minute.
Okay. Sorry, I can't hear you.
The negative sign in the middle between the parentheses when it's simplified into negative x squared minus.
You're thinking opposite of a negative? PEMDAS. Exponents first. Then you multiply. Yes, Lolly.
2x plus x squared.
Raise your hand if you got that. Okay. Class, is this the original problem?
No.
Okay. 2x, and then that one says negative, but this one's positive. Are you following? So I can't put in g of x. Or you can also do this. It's not equal to the opposite of g of x. What does that mean? An odd is that it's the opposite of what you started with. That's not the case, so it's not an odd function. I don't have the original problem, so it's not an even function. They call this neither. A neither is not the original problem, and it's not the negative sign or the opposite of the original problem. If you go ahead and graph that, you just have a parabola there, right? Go ahead and sketch that parabola. Class, is that symmetrical to the y-axis? Does it fold exactly on the y-axis? No, it does not. At the origin, is it symmetrical there? No, it's not. So it's not symmetrical and neither of those. So this is not an odd, not an even, it is neither. Alright, in this problem we're going to do the same thing. Class, read it to me on the count of 3. Ready? 1, 2, 3.
Replace every x with negative x.
So I'm going to replace each of these x's with a negative x. Do that. Oh, that one was squared. Class, what's negative x to the third power? Negative x to the third, yes? What is negative x squared? X squared. And then I have the 4 minus. I'm going to pull out that negative here. That's a negative 1, yes?
Yeah.
I'm going to pull that out in front. So this is a big negative sign. It's in line with the fraction line. Numerator, I have x to the third, and then denominator, I have 4 minus x squared. Class, do you see that somewhere? Is that equal to the original problem? Yeah. Every time you see x to the third over 4 minus x squared, what are you going to write? You're going to write h of x. I see x to the third over 4 minus x squared, so I'm going to write is equal to the opposite of h of x. When the problem is the opposite of what you started with, this is a odd problem. And I forgot the minus sign. Odd equals the opposite of f of x. Do you see that? Let's go ahead and graph it. So you have a rational function here. So when you're graphing rational functions, make sure you're starting with a, so the original problem's up here. You're going to put the numerator in parentheses. So parentheses, x, x, x. Close the parentheses, divided by 4 minus x, x. I'm going to press zoom 6. Standard zoom. And you're going to get a crazy graph. Now tomorrow's lesson will be about actually how to find the horizontal and vertical asymptotes. But for now we can do some sketching. You'll probably notice some asymptotes vertical asymptotes at 2 and negative 2. Let's go ahead and sketch that. Remember, the big idea is just kind of a quick sketch. So I have vertical asymptotes. Let's graph this in blue. So in this problem, it doesn't look like I can fold the graph on my pencil on the y-axis, right? Okay. This one, if you put a different colored dot right at the origin, everyone say origin? Origin. They call this symmetry at the origin. So let's write that where I fit it. Symmetry at origin. Here's an example. So if I just pick a color. If I put the order pair 1, 1, and I go to the origin, down, and then left, and I make the same L here, what's that order pair? -1, comma, -1. What does that mean? If I put in an x value, a positive x value over here in the original function, I will get that same value back, a positive. We put in a negative x, and we get a negative as our answer. Okay? So they call this an odd function. It's an odd function because when you algebraically put in a negative x, you get opposite of the original function or negative of that function, and it's symmetrical to the origin. You can probably also see tomorrow we'll talk about a slanted asymptote. Do you see it? So I'll put my pen right there. All right, here's my example. F of x equals 1 minus x to the 4th. Replace every x with negative x. So I have an x here, and I'm going to replace it with a negative x. So I have 1 minus negative x to the 4th power. Remember, something to the 4th power is just written out 4 times. Does that make sense? And if you put in negative x here, you can't put that in your calculator to help you. You can put in a -1, that's fine. Class, what's -1 times -1?
1.
And what is 1 times 1?
1.
So I have 1 minus, this will become just x to the 4th. I don't really need that parentheses, right? 1 minus x to the 4th. Okay. Now, if I look above at the original problem, it says f of x equals 1 minus x to the 4th. Every time I see 1 minus x to the 4th, I'm going to write f of x. I see 1 minus x to the 4th. Class, instead of writing that again, what am I going to write? I'm going to write f of x. I came back to the original problem. I see 1 minus x to the 4th. I'm going to write f of x. Let's graph this. Now on this graph, I'm not looking for detail, just kind of like a basic graph. Clear out what you got. So I'm going to type in 1 minus x to the 4th, or I'm just going to type in x 4 times. I have zoom 6, And this is what my graph looks like. Remember, you can always change the window. Probably not going to go higher than a y max of 2. This probably looks like -3 and +3, so let's change that. -10 is fine. Whoops, that should be -3. Sorry, go back. -3, +3. Y minimum, -10. Let's do a -100 here. Y max, 1, count by tens. Press graph. Didn't go high enough. Let's go Y max. And it kind of looks like a quadratic, doesn't it? Let's go ahead and do a quick sketch. Ignore that blue dot. It's not a curve, it's kind of like a plateau. It's kind of more flatter on top. Alright, just like a taco, you can fold it. And this is called symmetry. Everyone say symmetry. Look at the back of the class there. The heart has a line of symmetry. Fold it in half. Back there, the letter M. Look at it. The letter A, the letter T, the letter H. You can fold all of them. This is an example of a even function. What makes this even? Well, when I substitute in -x for every x value, I get the original function itself. So it's equal to f of x. Also, when I flatten out on the plateau, I can fold this. That's how I've proven it graphically. Okay? So here we can say it has symmetry to the y-axis. And here's a cheesy way that I'm going to remember it. I just put an L, so kind of like a vertical line, and then a Y. And it spells the word evenly. Okay. So when you're thinking about when is it even, odd, or neither, evenly means it's symmetrical to the y-axis. You can fold it in half there.
Where would you put end behavior? So 100 degrees. End behavior is correct here. Partner A, tell partner B the sentence we usually write for end behavior. Ready to go. Marissa, write us the first sentence. You can use blanks. First Marissa, there you go. As Alberta, can you read the second one? As there's a sentence for end behavior. Everyone talk to your partner, 10 seconds, ready to go. Alright, Marissa, you go first. as x. Well, we're not sure, so I'm just going to leave it as a blank. Alberta? A blank, right? Anyone else have anything else under the word even or odd degree functions? Anyone? Leading coefficient. Raise your hand if you knew that. Class, what does that leading coefficient do? So the big idea is that the leading coefficient will change the shape. So, for example, if you made something up like x to the 4th minus 8, and maybe put a negative here. Let's color code this. Our leading coefficient would change the arrows, right? And then this sentence is looking at the highest degree, right? Or easiest degree polynomial. Okay? What would you guys put under even and odd functions? Symmetry. What are the types of symmetry we had? Even, odd, neither. So basically, the even, odd functions represents symmetry, and we just did a bunch of examples like that above. So this is basically finding symmetry. Let's write that, symmetry algebraically. And now we're going to find symmetry Sorry. That should be graphically. Come on, mister. And this one is symmetry algebraically. So this is new. So let's write down some steps. If I give you a polynomial, the question is, how do you know if it is odd, even, or neither? And the answer is you're going to sub in negative x for every x. And then if you look at your results, it's going to be an odd if your answer is the opposite of your original. And that's why in the previous notes I had something called odd op x. It's an odd function if it's the opposite. So it's just kind of like a word on play to help you remind. It'll make sense when we do some examples. It's going to be an even if it's the original function. And it is neither if it is not equal to the opposite, and it's not equal to the original. So if it's not an odd, it's not an even, then it's going to be a neither. So this is how you test for symmetry algebraically.
Turn in just one